So in our last video we built a model of the air to glycol coils in the runaround loop, and it was its own sort of standalone use program, which I'm showing here, and it worked. You have all the units set, everything seems to work fine. So what I'd like to do in this video then is actually take this model and turn it into a procedure that can be integrated easily with a runaround loop or a system model. So the first thing I'm going to do is put these equations into their own tab. So I'll make a new tab, add a tab. We'll call it, I don't know, Coil tab. And we'll pick up all of these equations. So Control All and copy and paste and run. And it runs. You can see again the units are set and everything like that. And then we're going to save this tab. So if I have these in a tab, I can just save the tab. I'll find a place to put this, and we'll call it, we'll just call it Coil tab, I guess. Alright, so here is a brand new ease code. This is going to be where I actually build my runaround loop model. So I'll just save this as a runaround loop. Save as, let's see, I'll put it here, I guess. And we'll call it runaround loop. And I'm going to need in this model, the system model, I'm going to need models for the fan, which the two fans, which I'll get from the component library, and the gear pump, which I'll also get from the component library. But then I'll get the model for the coils from that ease model that we just built. So I'm going to open that tab that we just saved. So that's this right here. And now this is the model that we've just built of the coil. It should still solve. All the units and everything for all the variables should have come along with the tab, so that's nice. One thing I'm going to do here right away is actually save this variable space with all the units and all the guess values and the limits and everything like that. And the way that I do that is I go to the variable information window, and you can see over here there's two save buttons. The first save button saves the entire variable space of the entire ease code, which isn't really what I want here. I just want to save the variables that are local to this tab, because then I want to be able to have those same variables be populated inside of a procedure or a subprogram. So that's the local. The L here means local. I'll save that, and I don't know, we'll call this maybe I don't know, IC coil variables .txt. And if I go look at what I've just saved and find it here, it's just a text file, and it just has all the information for every single variable that's involved, sort of recorded here as a $var info statement. So I could literally type all these $var info statements at the top of my procedure, and it'll set all this information. Obviously that's kind of tedious, so what I'd rather do is just right here at the top of my tab, I'm going to put $include, and then IC coil variables.txt, and that's basically the same as having those statements right here. Alright, so let's see, the next thing I'm going to do is turn this into a procedure so that I can call it. So I'm going to need two of these tabs, one for the indoor coil, one for the outdoor coil, in case they're different. So I'll go to properties here and call this IC. So this is my indoor coil tab. I'm going to take all this stuff and throw it inside of a procedure statement. So procedure, I'll call the procedure or indoor coil. The inputs will be the inlet temperatures and the volumetric flow rates. And then I also need to input the concentration of the ethylene glycol. And the outputs will be the performance, so the ethylene glycol out and the air out temperature. And maybe I want Q dot, and maybe I want the effectiveness. and then somewhere down at the end I have to put the keyword end. And everything between procedure and end is my code, so I'll probably indent that to make it a little more readable, which I've done right here. So these inputs right here, these operating condition inputs, they're set in the input string, so I don't need them inside of here. I'll take that out and I'll put them down outside of the procedure, and they probably shouldn't be indented, so let's not indent them. But the geometry itself, that's set because it's a simulation program. So if I want to change the indoor air coil geometry, I would just come in here and change the geometry. I don't need to do that programmatically. And I can just quickly test that this works. I'll just call this. So down here, call indoor air coil, and I give it these inputs, and it should provide these outputs. So if I solve, you see all of the outputs. Here's all the stuff inside of the procedure itself. There's no unit errors because the units were set right here. And I can use a procedure because I'm not using equations in here. These are all assignments. This will basically there's no need for any kind of iteration. If I needed iteration, then I'd have to do exactly what I just did, but use a subprogram instead of a procedure. And in that case, having the guess values and the limits set for each variable would be actually very important. So I'm going to copy this and get rid of it here, and then I'll go into my main program, and now I can call this procedure that's in my tab from the main program, but only if I insert the procedure. So $insert tab IC. I think that's how you do it. And so now all the code that's inside of this tab will be inserted inside of my main code here. And if I run, you can see I can just reach into the indoor air coil and access this coil model right here. I need an outdoor air coil model as well, so I'm just going to add another tab, which I'm going to call OC for outdoor coil. And I'll take this information, this code, Control Alt, and copy it. And I'll just drop it into here and change the name from indoor coil to outdoor coil. And if I have different geometry for the outdoor coil, I would change that down here. Maybe it's 20 inches high instead of 30 inches, and it's, I don't know, we could even have different heat exchanger geometry. But now I also have to insert insert tab OC. So now these two models, which I spent some time building, I can access them from a system model in this fairly convenient way. It's not cluttering up my main program. So what we'll do in the next video is actually integrate these two coil models with the fan models and the pump model, which turns out to be not trivial, right? Because you have to be at the right place on the head flow curve for all the fans and the pumps relative to the system, which in this case is these coils.